This is electronic. I'm an old guy. Kid's doing this one.
Welcome back to WEGS Garage. A few weeks ago we tried to replace our gauge voltage regulator on our 1964 Triumph TR4, and we found that this one we had purchased was, well, not so great. Dead in the box. So today we're going to tear this thing open, take a look what's inside, and then for just a few cents worth of parts we are going to fix this voltage regulator and make it better than ever. And don't worry, despite what my dad says, very simple project. Let's do this. All right, so here's what's inside of our voltage regulator. I think a couple different companies make these. These are a replacement for the older style mechanical voltage regulators. These just have a single linear voltage regulator chip that's soldered to the board and then connected to the same pin out as the original part, so you can just swap it out, and the case kind of looks like the original. So this is a really simple, cheap circuit. Also looks to be somewhat cheaply made. The solder joints are not like the best I've ever seen, but maybe could have something to do with why this one does not work. We are going to take this same concept and take this chip off and replace it with something a little bit better. Okay, so to replace the circuit that was on there, here is what we're going to do. This chip right here, L7810, is very similar to what is on here already. It is a chip that takes in 12 volts and connects to ground, and on the output side you get 10 volts. That's the 7810. The difference between what we're going to do here and what this chip has is that we are also going to add a couple of capacitors on the inlet and output sides of the chip. And what those are going to do is help to smooth out the voltage coming into the chip. The reason for that is these are a little bit susceptible to voltage spikes and dirty voltage and stuff like that. So it's possible that that could be what contributed to this one failing. So putting a capacitor on the input side should help with that a little bit. On the output side, the capacitor will help smooth out the voltage that's being supplied to our gauges on our car. So we're going to create this circuit on this board and get all of this stuff crammed back in here. And the great thing about it is all this stuff, you need a chip and a couple of capacitors. You may already have some of that junk around if you mess with electronics. I didn't, but I bought all this for probably around $15, and that was enough to make like probably like 20 of these things, which is a little overkill, but it's cheap. The parts are cheap, and it should be better than buying another one of these, so I'm excited about that. Alright, so this is just another way of looking at the circuit here. I've made it a little bit clearer what pins go to what. We have our 12 volt coming in over here. That's from your battery. And then this is the voltage regulator chip that we're going to be installing. And that has 3 pins on the bottom. And that first one on the left side, when you're looking at it like this, connects to your 12 volt. The middle one connects to ground. And the one on the right side is your 10 volt out to the gauges. So that's the main part that we need to hook up. And then the two capacitors just need to go from the 12 volt input power to ground. So that's right here. This is a little ceramic capacitor, 0.33 microfarads. I don't think the size is all that critical, but something around that range will work. You just hook that in with the incoming power and the other side to ground. And the same on the output. That's a 0.1 microfarad, and that looks like that. Same thing. So as far as setting this up on the board goes, the way this was manufactured originally, this component was surface mounted to the board, but I didn't really like that. It makes it kind of hard for a DIY person to solder, so I actually drilled some holes through the board here to mount these components in the order shown on the diagram here, to actually mount them to the board. So on the back side you have your B terminal. That's where your 12 volt incoming power goes. There is a trace that comes right over here to this right side. I drilled a hole there, put the chip in there, and also the capacitor. The center pin goes to the ground location on this board, and the one on the left is connected to the other side of the input. That one's labeled I. That's where your 10 volt out to your gauges goes. The ground is connected to the case through these little traces on the outside that just contact the case, so that ends up being your ground. Because they manufacture this in both positive and negative ground, they don't actually hook that up, so you just have to put a little bridge of solder in this corner between the ground and the actual ground pin on this, depending on whether your car is positive or negative ground. With everything on there like that, the last step is to get everything soldered up. Alright, here's the moment of truth. We're going to hook up power, see if we let any of the magic smoke out of there. Hopefully not. You can't put it back in. Alright, here we go. Hooking it up to 12 volts. Nothing glowing or popping, making any noise. Good sign. So now we just have to check our output terminal. Dad doesn't quite have enough hands for this. Well, what do we have here? 9.98 volts DC.
It works. 12 volts going in. Actually, I measured it before we hooked it up. It was 13.3. 12 volts going in. Well, you can see it, 9.98 output. Good job, kid. It works.
Yeah, try sometimes. All right. Hey, so now I get to go back and install this. So that means back into that tunnel. Hey, here we go. All right, well, we'll see you later. Oh, these seats are so comfortable. got there, Pop?
This would be your Voodoo Ranger Juicy Haze IPA. Tasty.
All right, so that's all there is to it. We got our new gauge voltage regulator put in for just a few dollars worth of parts. We were able to fix that ourselves better than ever. I want to put a couple thanks out there. There's a couple of posts on the Triumph Experience message board about this exact same thing. There's also an article for MG on how to do this same sort of conversion to your old original gauge voltage stabilizer. And I kind of adapted those for this. So thanks to those people. Also thanks to a WEGS Garage viewer, Mr. Walkman, who definitely helped me out with selecting some of the components and even designed an even better circuit that is reverse polarity protected. I didn't have time to get the chip needed to make that happen, so we just kind of went with it. But thank you anyway for your help on that. That's about all we got time for today. Thanks so much for watching. If you have any questions, please post them down below, and we'll see you next time. Cheers!